Now the next area I want to discuss here is Archimedes' principle. Now Archimedes' principle is a law of physics stating that the upward buoyant force exerted on a body immersed in a fluid is equal to the weight of the fluid the body displaces. In other words, an immersed object is buoyed up, it's kept up by a force equal to the weight of the fluid it displaces. So not the weight of the object, the weight of the fluid it actually displaces. Now Archimedes' principle is an important and underlying. If a sealed 1 litre container is immersed halfway into the water, it will displace a half a litre of water and be buoyed up by a force equal to the weight of half a litre of water, no matter what is in the container. If such an object is completely submerged, it will be buoyed up by a force equivalent to the weight of a full litre of water. In other words, 1 kilogram of force. This can be demonstrated here by looking at this picture. As you can see, the object has a density of 500 kilograms per metre cubed, and this will have a force known as gravity acting down on it, as you can see. Now when placed in water, it will experience an upward force known as buoyancy, which is equal and opposite to the force of gravity. Now because the object's density is half of the density of water, it will only displace half of its volume. Do you see that? Because the object's density is half the density of water, it will only displace half of its volume, as you can see here. Now what if the density of the object was 750 kilograms per metre cubed? Well, it would displace 3/4 of the object. Do you see how that works? Now what is the force of gravity? Well, the formula to determine the force due to gravity is F equals ma, where F is the force in newtons, m is the mass in kilograms, and a is acceleration due to gravity, which is m metres a second squared. So what is the force acting on a 3 kilogram block of wood? Well, put it in this formula here, F equals ma, you get it out, 3 times 9.81, the force is 29.43 newtons. Now, let's look at this here. Consider a 1 ton block of solid iron. As iron is nearly 8 times denser than water, it displaces only 1/8 of a ton of water when submerged, which is not enough to keep it afloat. However, if you made a ship out of steel and made it much greater volume, then it would float. It still weighs a ton, but when it's put in water, it displaces a greater volume of water than when it was a block. Now, the deeper the ship is immersed, the more water it displaces, and the greater the buoyant force acting on it. Now, when the buoyant force equals 1 ton, it will sink no further. Okay, that's how it works. Let's do an example. A ship weighs 100 tons and it's got a total volume of 120 metres cubed, with a volume of 97 metres cubed to the ship's deck. Now, what we have to determine is, will the ship sink below the deck? Will it sink? Well, we know that the ship weighs 100 tons. We also know that this force will be balanced by the force of buoyancy acting upon it. What we have to determine is what volume of water will be displaced. Well, the density of water is 1,000 kilograms per metre cubed, and therefore as 1 ton is 1,000 kilograms, this will displace 100 metres cubed. Now we know that the volume to the deck is 97 cubic metres, and it's 100 metres cubed will be displaced, and therefore in this case the water level would go above the deck, and in this case the ship would sink. Because the 97 is not enough, it would displace more and it would go over the deck and it would sink the ship. Yes, it would.